Hey Algebra team, and welcome to the next unit. We've spent the last few weeks mastering the art of keeping the scale balanced with equations, but now we're moving from the abstract to the visual. This unit is all about answering one big essential question: why are graphs useful for modeling real-world data? This week we stop just solving for x and start seeing how x and y work together to tell a story. Before we can model that data, though, we have to remember where we are. You've seen this grid before, the coordinate plane. We've got two axes on the coordinate plane. The one that goes horizontally is called the x-axis, and the one that goes vertically is the y-axis. And you may have heard the x-axis called the independent variable and the y-axis called the dependent variable. This point right in the middle, where the two axes meet, is called the origin. And then these two axes divide the coordinate plane into four sections, and we call those sections quadrants. And we number them starting in the top right. This is quadrant 1, and then we go counterclockwise. This is quadrant 2, this is quadrant 3, and this is quadrant 4. So today's big vocabulary words are intercepts. Think of an intercept as where our line hits or crosses a specific axis. The y-intercept, that's the point where the line crosses the y-axis. And in a real-world problem, this is often the starting point or the setup phi. The x-intercept is the point where the line crosses the x-axis. So if you look at this line on the screen right here, our y-intercept is at -4. That is the spot where the line crosses the y-axis. And our x-intercept is at 2. That's the spot where the x-intercept is intersected by this line. Or I'm sorry, where the x-axis is intercepted by this line. Now there's one more term you need to master, and that is the zero of a function. In Algebra 1, a zero is just the x value that makes the y value equal to 0. It's the x value that makes the y value equal to 0. Well, this point right here has a y value of 0, so that must mean the x value is 2. That is called the zero of a function. Now hopefully you're seeing that there's a little cheat here that you can use, which is that on a graph, the zero is the exact same thing as the x-intercept. So the x-intercept is 2. That is also the zero of the function. It is 2. So if I ask you for a 0 right here, the 0 is 2 because if I were to take this x value of 2 and plug it into the equation that was used to get this line, the result would be 0. This week we aren't just drawing lines, we're investigating the family of linear graphs. We're going to be using a graphing calculator as our primary discovery tool, and we'll see how changing a single number in an equation can tilt the slope or shift the entire graph up and down the wall. This is how we use math to make predictions about the future. So, your mission is to complete the guided notes that you have. I want you to draw 3 different lines on your grid paper. And for each one, I want you to label the x-intercept, the y-intercept, and the 0. And you're going to bring those to class next time, your 3 different lines that are labeled with the x-intercept, the y-intercept, and the 0.